sure that I don't lose a lot of progress. Okay, let's see what happens now if I start it up. Uh, Visually, it does what it needs to do, but visually it's kind of nasty, right? Does anybody have an idea what I should change?
Speed.
Sorry?
Well, now you're defaulting once every 10 seconds, right?
Yeah. Okay. I can make it. But that's not gonna solve my problem.
Determine the plot size.
Yeah, I wanna have. I don't wanna have my plot changing the whole time, right? This is nasty. Okay. So I looked it up before. Xlim apparently does the job. I didn't know this. I just had to look it up. So. Okay. Let's see again. Oh, that's pretty cool, right? Oh, it's just when it touches the border, it disappears for a moment. So maybe I have to make it a little bit bigger, the border. Okay. A lot of times it's a nice idea to push this button. If there's a lot of plots in your window, it gets really slow. And if you just remove all the old plots, it gets quick again. Okay. This looks good, right? We only still need to do the sticking. Agree? Well, that's more what we have to do, but no, it's not too bad. How are we going to do the sticking? Does anybody have an idea? What do we need to calculate for the sticking?
We need to compare the position of the moving agent in comparison to the stationary agents.
Yes. So I have to check all the agents. So what is my first step? What am I gonna write here? At this position. There's a lot of talking, a lot of negotiation between Chris and Bastiaan. I, I, I want to loop through all the other agents again. So I'm gonna go with a new loop, but in this case I'm gonna call J. Well, I don't know why. But I want to know for the distance between this agent and all the other agents with status 2, right? I don't want them to check it with this one. I just want to have it only with the one with the status 2. So my first action will be if status J is equal to 2, then it's okay. What I've got now, my agent which is moving is the one with the I, and if I do something like J, then it's the one where I'm checking it with. Does everybody see that? Okay, what should I do then? What should I calculate now? The Jacob group has a lot of discussion going on. You can share it also if you want.
Yeah, I have a question. You have two places where you have the status, like you just said, but one of them is in between brackets, the if one, and the other one isn't. Is there a difference, or doesn't matter?
There's no difference, but it's
Okay.
it becomes important if you do things like this with the or. So what I did for myself is always put in brackets, but sometimes I forget it.
Okay. Okay.
Both work. Let's say it like this: putting extra brackets is never a problem. Putting in too little brackets, it's sometimes a problem. So,
Okay.
so in this case, I can skip the brackets, but it doesn't hurt. Also, it doesn't hurt. So, it's okay. It doesn't matter. What should I calculate? What do I want to calculate with I and j? Does anybody have an idea?
The distance.
Yes. Does anybody know how to calculate the distance?
No.
Ever heard of Pythagoras? Yeah.
No.
So we're gonna use Pythagoras, and we're gonna use Pythagoras in a little bit different way. The long side of a triangle is actually equal to the square of the other two distances squared. So let's see. This is actually Pythagoras in a little bit different way. Yeah? Okay. So the distance, I need to calculate the distance. I need to first know the delta x. Well, I've got x, y minus x, j. Is it this, or should I do it xj minus xy, xi? What is the best? Should I do it like this, or should I do it reversed?
Part of the time it will be negative, but it will be squared anyway, so I don't think it
It
matters.
doesn't matter. It doesn't matter. Yeah, exactly. Because I'm gonna square it anyway. Both is okay. Absolutely. I'm gonna square it anyway, so I don't care. Is this squared? No, it isn't, huh? This is squared, I think.
That's squared indeed.
Okay, and this is y, and this is y. So this should be this formula. Does everybody agree? Yeah? Okay, cool. If distance, let's say, smaller than 1 meter, then I want them to stick. What should I do now? What should I change if they're sticking?
They change status 1 to status 2?
Yes, absolutely. Which thing should I write here in between? I or J?
I.
You're right, but why?
Because J already has status 2, right?
Yeah, J is the one where we are comparing it with, where we're checking the distance with. I is our active agent. I was the one where we're doing all the stuff for. I is the one where we're moving it, etc. So exactly. I should make it to 2, eh? Right?
Mhm.
Okay. And what should I do more? Yeah, continue.
I'd say the speed becomes 0, but
Yes. Very true. And again, the Y, the I mean. Something like this? Yeah? Shall we run it?
yes.
Oh, this takes too long time, right? That's boring. I'm gonna change this one to 10 again. So it's still the same simulation, but I'm showing it less often. I hope it oh, endless loop or not? No, not really endless loop. Come on. Doesn't stick?
I think you have to change the position of the first dot to 6, 6.
Yeah, let's do it like this. Then I'm pretty sure it's gonna stick. Yeah, okay. It sticked. Yep. But what is the next step I need to do? Because this is kind of boring, sticking one particle, right?
More agents?
More agents, exactly. And there's multiple ways to do it. I'm gonna do a simple way, and it's not the only way to do it, but in this case I'm gonna have a counter which is the active agent. So which is the last agent which I made active. So let's see which is the last agent which I made active. That's this one, right? And what I'm gonna do, I wanna have like each 20 time steps I wanna have a new agent, or each 100 time steps. How am I gonna do that? How can I do only one thing in like 100 time steps? Does anybody have an idea?
The modular.
Exactly. 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 And I'm gonna make it 99. So that means that it will not start with a new agent straight away, but just after some time it will get a new agent. You understand, Eric? Eric, you're looking really like pensive.
I am typing the same as you.
Okay.
But mine, it gives an error on line 40 or 39. The distance is an equation.
Oh, do you have
Error.
the Appian NumPy? Did you have NumPy imported? Yeah.
Yeah.
Okay. Okay. Yeah, maybe one bracket too much or too little or something like that.
Yeah. Could be.
You can share also if you want. Then we can check.
It says the array used as indices must be of integer or Boolean type.
Okay. Can you share your screen, because I think I know where.
I see the mistake.
Okay. Okay.
But it. Okay, fixed.
Okay. What I'm gonna do here is first make active agent one bigger. So it was one, now it's two, which is nice because I want to have the third agent, right? So and that's the, let's say the value in between the brackets is then should be 2, right? So what should I type here? Sandra?
1.
I heard somebody say the answer.
That's 1, right? Because make it active.
Yeah, it's 1. Agree, everybody? Why do I have still this one here?
You're missing an equal sign?
Yes. That's nasty, right? But okay. What should I do more?
Give it a speed and a starting position.
A speed and I want to give it a random speed, because so I need random.
Sorry, Bart. What was the difference between the second and the first if the percentage then is equal to?
This one you mean? This one and this
Yeah.
one. Okay, this one I'm using to plot it,
Yes.
and here I'm making a new agent active.
Okay.
And that's also why I put here 100 and here 10. So I want to, each 10 times I plot it, a new agent becomes active.
Okay.
Good question.
Got it.
I'm just gonna give it. I don't change the X and the Y position. It's possible, but I'm gonna give it like a random position, random speed in one of those directions. Because what comes out of this thing is like a number between 0 and 1, and I divide it by 10 to have the speed a little bit slow. Oh, it's still running. Oh wait, oh it was running. 1. This one is kind of boring, the one going up and down, right? Oh, this is boring. Let's do it again. Ah, this is better. My snowflake is growing, right? Any requests?
I think we can also add a one like another place from which the points would like be starting.
Yeah.
So it would be more equally
Yeah.
distributed.
Okay, we'll do it next. Oh, why is this happening? It's giving an error.
There is no place for for the agent to travel actually.
Yeah, what happens? I made more than 20 agents. So active agent is more than 20. Oh, no, not more than 20, it's 20. And what he says here, index 20 is out of bounds for access 0 with size 20. And it's in this line. What does that mean? Exactly what Jacob was telling. Status, if I did it like this, it's got 20 places, which means from 0 to 19. The 20th place doesn't exist. So he says you want to put somewhere in a cupboard, but the cupboard is not so long. That drawer doesn't exist. Okay. Let's. Where do you wanna? Somewhere like here, Jacob. Oh shit.
Yes. Sorry. What?
So you wanna have also the position X and Y from a different place, right?
Yeah.
Okay. Now I'm something like this. It's still on one axis, but it's like a different starting points.
Yeah.
For the Y. Okay. Let's see. Oh. Oh shit. Yeah. Wrong. Tuck. So it's coming from the left axis, Jacob, on a different position.
Why do you do times 10 instead of divided by 10?
Well, this number is between 0 and 1, what comes out of it. And if I would do it between 0 and 1, it would only be here. So that's a little bit boring, Eric. So I want to have it from 0 to 10. That's the reason.
Why does it only go by 0 to 1? Where do we state that?
That's just
random int?
That's just this thing. It gives out a random value between 0 and 1. I looked it up. I don't know why it does it like that, but that's just what this function does, Eric.
Okay. Okay. Yep.
I can check, eh? this is actually what I did. I just copied it from some online. I want to have a random number, and then I did this, Eric, just to see what comes out. I was too lazy to read the documentation. Yeah, seems like between 0 and 1. Okay. Hey, is this clear? And of course, the rules are extremely simple. I'm not making a really complex agent-based simulation, but this is basically how I would start. Basically, all this thing, it's for all your agent-based simulations going to be the same. I think you need to loop through time. You need to loop through agents, and then this stuff is going to be different. This stuff is probably also going to be the same. You want to show it. And here, well, you can have different ways. And this part will be the complicated part in your cases. But a lot of times this part, like the moving it, will also probably be the same. Yeah, is that clear for everybody? Does it help? Okay. Then I'm gonna do. Okay. Let's see. This one was the one I made earlier. I think I. No, it's pretty similar, right? I had a cheat sheet next to me, but it took me maybe a little bit longer than what it took me today. It took me now 3/4 of an hour, right? I think. So. And I don't mean that this is what I expect from you, but this is like the start, I think. Shall we do the other type? The differential stuff. Is that okay?
Bart, small question.
Yeah.
We just joined because we had a meeting with our project owner, but is this being recorded?
Yes.
Perfect.
Okay.
Thanks.
Well, I can show you a little bit who asked the question.
Me, Mauric.
Yeah, Marik. So what we did, we defined X and Y for a number of agents, and we defined the speeds, and we defined the status. Then we gave them a couple of them a starting position, and the idea is what we made is a simulation in which snowflakes are sticking to each other. And what we did here is like, well, this is actually the one I prepared before. This was the one we made. We just said new position is all position plus speed times elapsed time. If they got into the border, we switched the speeds. If they were close to one which is standing still, then we said the speeds are 0. That's this part. This is where we show it, but not all the times because that gets boring. So only 1 in 10 times. And here we make new agents. But it should be in the movie.